Today's topic is stability in control system. I am Mr. Govind Samleti, Assistant Professor in Department of Mechanical Engineering from Walchand Institute of Technology, Solapur. Learning outcomes. By the end of this video, students will be able to understand the concept of stability in control systems, identify different types of stability and their significance, recognize the importance of stability in real world engineering applications. This is the content, concept of stability and types of stability. Concept of stability. Let us define this system. A system is said to be stable if, after applying an input or a disturbance, the output remains finite and returns to equilibrium over time. Stability ensures that the system performs its intended function without unpredictable behavior or failure. Types of stabilities in control system. The first type is stable system. It is also defined: a system is stable if its output remains unbounded for any bounded input and eventually settles to a steady state. Let us see an example of this system. Here it is a container and here is object. When the force is applied to an object, let us see how it is behaving. Right? The object is settled inside the container. Right? And if we apply more force, then what will be the effect inside the container? We will see that. So here we can see that the object is fell into the container and it has oscillated for some particular time and eventually it has settled to rest. Right? So such kind of systems are called as stable systems. The end result will be stability. Eventually, when we can take the example of this system, in that the object has initially some disturbance, but eventually after a particular period of time it will come to a rest and it will have a constant value. That is called as a stable. Okay, so let's see the next one. Unstable system. Unstable system is unstable if a small disturbance causes the output to grow indefinitely without settling. Now let us see an example. Here we can see the object is on a particular tip. Now we cannot predict that the object will fall on the right side or on the left side. Right? It is indefinite. Okay. So let us observe that if the object will be having a particular path, we cannot say it. Right? So such kind of systems are called as unstable systems. We cannot predict the stability of system at any time instance. Okay. Now there are some systems which are conditionally stable. Right? That is called as a conditional stable system. A system is stable only for a specific range of parameters or a condition, but becomes unstable outside this range. Right? Now let us see a vessel with an object, and if a force is applied to it, it will eventually fall into the vessel and it will be at rest after a particular period of time after oscillating. Right? And if we apply the more force to a particular object beyond the range, beyond its range, right, then it will fall out of the container and it will be in unstable condition. So here we can see that when the force or the particular signal or the force is within the range, the ball or the object will be inside the container, and eventually after some time it will be unstable. Okay. Now let us see one more example, the marginally stable system. There are some systems, for example pendulum, where systems keep on oscillating when certain force is applied. Such systems are neither stable nor unstable, and hence called as marginally stable system or critically stable system. Now in this, there is a pendulum which is fixed at a particular point, and when we apply the force it will keep on oscillating, right? This oscillation is neither stable nor unstable, right? Such kind of systems are called as marginally stable or also called as critically stable system. Okay. Now we can think about a particular pendulum, right? A system equation can be generated of the system equation can be generated of a pendulum, right? And by using a characteristic equation, we can define the poles on the S plane, right? And we can see the location where the poles are located inside the on the S plane, where the poles are located on the S plane. Generally, when the poles are located on the imaginary axis of the S plane, then the system is said to be marginally stable, right? And when the poles are located on the left hand side of the S plane, then the system is called as stable, which is on the negative side. And when the pole or when the poles are on the right hand side on the S plane, then the system is called as unstable. Okay. So these are the references. You can refer the Mechanical Measurement and Control Engineering by D.S. Kumar, and Principles of Control System by U.A. Bakshi and V.U. Bakshi. Thank you.